All right, this is going to be the video for week 3, dysrhythmias, COPD, and asthma. Starting off as we do with the same order that we did in class. So we're going to start with dysrhythmias and EKG. So for dysrhythmias, it's going to result from disorders of impulse formation or conduction, or it could be both, right? So what does that mean? The heart has the nodes. So here we have the SA node and the AV node, and this down here is going to be the Purkinje fibers. There's a few other stuff in there that we're not going to discuss, but this is what is basic, right? This is what we're going to cover right now. So the impulse starts on the SA node. Okay, these are the pacemaker of the heart, right? So you have the SA node is going to conduct electricity. It's going to go to the AV node and the Purkinje fibers, and it's going to tell the atria to contract, and then once it hits the Purkinje fibers, it's going to tell the ventricles to contract as well. Okay, so it's a specific rhythm, and we'll see how that translates onto the EKG in a second. So what the impulse formation and the conduction of impulses disorder means is either it has trouble forming the impulse, so the nerves that are starting this chain reaction aren't functioning, or there's a trouble conducting. So think of it with electricity, either the cable of the charging cable for your iPhone is messed up, or the brick is messed up, right? So either you have a problem receiving the energy, or you're having trouble transmitting the energy, or it could be both, okay? One thing to note with dysrhythmias is we always treat the cause of the dysrhythmia. Okay, so always treat the cause. Dysrhythmias occur as a result of various abnormalities and disease states. The cause of dysrhythmia influences the treatment. So we're always going to treat the cause. Okay? So we're going to take a second to look at the EKG and how to read it. So on your EKG, we're going to delete this. On your EKG, it's a grid format, right? So we have our grids, 1, 2, 3, 4, 5. And this is a zoomed in picture of the grid. This is one square, okay, of our grid. So here's our grid. We're gonna look at 1, 2, 3, 4, and 5. Each one of these squares is gonna be 0.04 seconds. So this square right here, 0.04 seconds, okay? So 0.04. Now, there are, how many did we say? 1, 2, 3, 4, and 5. So 0.04 times 5 gives us 0.2 seconds, okay? So one square on your EKG grid is gonna be 0.2 seconds. One small square is 0.04, okay? Don't make that mistake. They'll give you a bunch of different answers, right? So now let's look at how long each interval should take. So we know we have a PQRST, right? So I'm gonna try to draw this the best way that I can, right? So we have a P, and then we have the Q, R, S, and T, okay? So here we have the P. This is atrial, right? So this is what determines if it's sinus or not. So the P wave, we have Q, we have R, we have S, and we have T, okay? So the T's are our waves, the QRS is the QRS complex. So this is your atrial, this is your ventricular, and this is the reset, right? This is kind of like the repolarization of everything, where everything comes back to baseline, and then you have your isoelectric line right here. Typically after this, in a normal sinus rhythm, should come another P wave, and then the cycle repeats all over again, okay? So isoelectric, ST segment, our P, this one should be straight, okay? boom. And it repeats all over again, okay? So typically, our P wave, right, should be from 0.06 to 0.12 seconds, okay? So our P wave alone, so our P from here to the start of the Q is anywhere from 0.06 to 0.12, okay? So that's like slightly over one small box to, what is that, 2 small boxes, okay? So that's our P wave. So that's the normal range for our P wave. This is all gonna make sense in a minute. We're gonna tie it all. The PR interval should be 0.12 to 0.2. So what's our PR interval? From P to R, right? So that's our PR interval. So from here, 0.06 to 0.2, okay? So it can be as long as one big box on our EKG line. Now that's the time it takes for the electrical impulse to reach the ventricles, okay? Now the QRS complex is going to be from 0.06 to 0.12, right? So this is the QRS. So here's our Q, here's our R, here's our S. This should be pretty narrow, right? So 0.06 to 0.12, that's pretty narrow in its own right. 0.06 to 0.12. So this has a quick conduction rate. Okay, so that's the ventricular contraction or depolarization. And now we have our T wave, which is 0.16. So 0.16. Okay, now our board looks pretty messy, right? And that's the ventricular relaxation. So T wave is relaxation. It's T time, right? It's T time. You sit down, you take a break, your ventricles relax. QRS is the ventricle. You can see it's a V or a upside down V for ventricle. And P, you just remember that's atrial, right? So we have our P wave. Atrium starts everything off. We start off with our P wave. Everything starts off here. QRS, it looks like an upside down V, V for ventricle. And then T time, the ventricles relax. Okay? So let's go ahead and look at how to determine the heart rate on a 6-second strip. Okay? So remember, this is called the 6-second strip. We have 6 seconds of a EKG reading. So let's go ahead and delete this as well. Okay, so let's say we have 6 seconds of our EKG. Let's see here. I'm gonna try. I just gave him a STEMI. Q R S T P Q R S T P Q R S T P Q R S T P. Okay. Imagine this is normal sinus. We're not getting into the rest of it yet, right? This is still normal sinus. So let's say this is 6-second strip. Okay, in 6 seconds, this is what the EKG popped out for us to read. Okay, our first question, our first criteria is how many QRS complexes were in that 6 seconds. Okay, so this is counting R's. You're counting reps. Okay, think of it, you're counting reps in the gym. We're here, we're counting R's. Remember, our R's are our peaks. Okay, this is an R, this is an R, this is an R, and this is an R. Okay, so how many R's did we get in 6 seconds? 1, 2, 3, 4. We have 4 R's. Okay. In 6 seconds. Why is 6 seconds important? Well, we're trying to determine beats per minute, right? We're trying to get to our BPM. So how many 6 seconds do we have in a minute? We have 10, right? So whatever number R is, we're gonna multiply by 10, and that's gonna give us our beats per minute. So this poor guy has 40 BPM, okay? 40 beats per minute. That's below normal, but stick with it for now, okay? So that's our first question, is how many QRS complexes, okay? That's how we're gonna get to our beats per minute. Our next question is gonna be, is it regular, okay? Now, what determines regularity? When we're assessing in our head-to-toe assessment, or when we're doing palpating for pulses on a client, what we're gonna do is we're gonna do the bilateral check, and we're gonna say, yeah, those pulses feel like they're coming in at around the same time. They're equal in strength, they're equal in rhythm. Okay, that's when we're saying that the beats per minute is regular. Okay, now how do we determine that on a EKG strip? I can't feel the electrical impulses on the EKG. So what we're gonna do is we're gonna measure the distance between the R's. Okay, because each R, each peak, each QRS complex gives us that heartbeat, gives us that ventricular contraction. So we're gonna go ahead and we're gonna measure, here's this R to R. Is it the same as this R to R? Is it the same as this R to R? If our answer is yes, then it's regular, okay? So for the sake of, because I did this freehand, let's be generous and kind. Let's say that this is regular, okay? The distance between this R to R to this R to R and this one to this one is the same, okay? It's regular. Now, something that isn't regular, look at this bottom one. Here's our P, Q, R, S, T, P, Q, R, S, T, and then P, Q, R, S, T. Okay, notice how this one and this one have a nice gap between them, and this one and this one are a little close, right? They're close friends. So now I cannot say that our rhythm is regular because our contractions, our ventricular contractions, are happening at different intervals of time. Okay, so question 1, what's our BPM? Question 2, is it regular or irregular rhythm? Okay, now question 3, is there a P wave? Okay, on something like this, we can see P, Q, R, S, T, P, Q, R, S, T, P. There's a definitive P wave, P wave, P wave, P wave, right? You can take a look and you can just see that that bump right before the QRS complex is present, okay? Is there a P wave? Now, if there is a P wave, that tells us it is a sinus rhythm. Okay, so P equals sinus. Okay, so why is this P is sinus? The nodes on the heart, so the SA node is also the sinus node, right? So the P, we said P is for ventricular contraction, which starts at the sinus node. Okay, so here we have our heart. Remember, that's a weird looking heart, right? So here's our SA node. Our SA node is the sinus node. That's where our atrial contraction begins. That's where this whole chain starts, right? It all starts with a P wave, okay? So if we have a P wave present, we said that it is sinus rhythm. Now, this is where more of the math part comes in. This is where we go back to the small boxes and big boxes. Now we're gonna go ahead and we're gonna measure the QRS time, and we're gonna measure the PR interval. Okay, so we're gonna measure the distance. Well, we're gonna measure the distance between P to Q. And then we're gonna measure the Q to S interval, right? So we're gonna go ahead and measure the times it took for all of these, okay? So let's go ahead and let's look at our reference. So we have the PR and we have the QRS, sorry. So the PR and the QRS, okay? So our PR interval, we said the regular PR interval was 0.0 0.06 to 0.2. Okay, or sorry, 0.12. Forgive me, these numbers are all getting jumbled. And then we have our QRS, which is the quicker one, which is 0.6 QRS, which is the ventricular contraction.